So today's content is about working with SolidWorks non-native files. As we're aware, there's a ton of different CAD data that exists out there in the realm of engineering and beyond. And we're going to talk a little bit about what to do with this data or this information that we aren't able to directly pull into SolidWorks and begin manipulating. My name is Nathan Kabachin. I am the lead technical support engineer here with DesignPoint, in addition to just being an application engineer. So delivering content like this, seeing you guys on support, etc. Without much further ado, let's roll into this topic. So the content we're going to cover today is going to be, we're going to do a brief overview on types of CAD data, some of the import options that we sort of have available to us, and talk through that a little bit, what 3D Interconnect is, and then we're going to talk a little bit about effectively what can we do with the file that we're importing in, and different methods to address that through import diagnostics, check entities, feature recognition, and direct editing. So we're going to talk a little bit about a workflow process there, and then a little bit more beyond that. We'll also have a demonstration at the very end. So we're going to touch on these subjects lightly, and then we're going to demonstrate what we can play with in real time. So for types of CAD data, types of 3D CAD data, these are just a smattering of them. Now this is everything organized in order of preference that SolidWorks likes pulling into it. Now there are things beyond this that SolidWorks could utilize, but if you've ever worked with parasolid models, step models, IGES models, looking at this from a hierarchy of preference as they import into SolidWorks tends to be helpful for two reasons. One, if you are a SolidWorks user yourself and you know you've got to send a model to another SolidWorks user or some other vendor, it's relevant to try to export your models as something that you might more easily import later, especially if they are also using SolidWorks and you don't want to send them a SolidWorks file with a feature tree fully accessible. These are things that are worth considering. The other bit of it is that if you are seeking CAD data from a vendor, it's best to know what types of file extensions you can ask for or prefer from them. And if they're available to give them to you, this hierarchy should help to provide you with a best case scenario for opening your files. One thing worth noting, Parasolid is the preferred method. If you look down at the, hold on, I'm going to end our slideshow just so that I can verify that things are working here. Give me just a moment. Pardon the technical difficulty here. Appears that there is a lag or delay in my screen. So let me pick up where we were just previously. These are, again, are the types of CAD data that we have available to us. Top of the list here being Parasolid is the most preferred method for importing. And if you see at the bottom of the left-hand side, there are IGES files, which, again, that bold statement at the bottom informs us that the last time these IGES format was updated was in 1996, when it was originally developed by the Air Force. So it's not a bad format, but it is one that you've got to recognize you're limiting yourself on the type of information you're going to get out of it. Let's take a look at our next slide here. So the types of CAD data, let's talk about the limitations a little bit here. So if we are looking at specific CAD systems or CAD softwares that we generally import into Solidworks, those might be things like Creo, Unigraphics, Solid Edge, and Autodesk Inventor. There's a number of other softwares out there, but here are the sort of most commonly used. Each one of them has a slight limitation to it. We're not going to walk through every single one, but it's relevant to me that you see and understand that the translation from one software to the next is never perfect. We'll pull out Creo as sort of the best case scenario. Imports and export parts and assemblies, it's good at translating that information, not as good at translating any of their sort of drawing information. Import body, date, feature date, and mate date, or data, excuse me. Again, it's good at reading that information, but there's other things like material selection, so on and so forth, that it's not necessarily going to pull through. So you're never looking at a one-for-one scenario where all of your data is going to pull through perfectly. Apologies for the slight delay again. It appears as if we're having a screen sharing malfunction.
Hey, Nathan, can you hear me?
Yes, the other attendee ended up leaving, likely because this was being weird. Get out of here.
Looks like we're good to go now.
What's up?
It's all working now.
Whatever. All right. Is there a way to like stop broadcasting so I could just record the dumb thing and then we're good from there?
I think if you just kill the webinar, it'll do it.
If I kill the webinar, can we get back into it? Or will it count the meeting as completed?
It might count it as completed.
Freaking gosh, this thing is. So it's good now. I just want to verify that. I did literally nothing different other than like I spammed the share screen thing like on and off, and then apparently it just took. So
finally took. Huh.
Like, are you able to see me changing slides live?
Yeah, you're changing slides now. Yep.
Such a beneficial amount of time.
Maybe, I don't know if they can edit the video. Maybe if you start the webinar over at this point now.
I think that's probably what we're going to try and do. So let me hit. Good morning and greetings, everybody. This is Nathan Kabachin here with DesignPoint. Here to talk about working with non-native Solidworks files and effectively what we can do with them while trying to introduce them into our CAD workflow. I'm a tech support lead here at DesignPoint, as well as just a general application engineer, where I deliver content much like you're absorbing right now. And also, I see you guys on support and training as well. So without further ado, let's jump into this. So the content that we're looking to create today, or the content we're looking to cover, is talking about two major categories. One is just talking about the process of importing, a little bit of background there, talk a little bit about the options and what 3D Interconnect is and does. We're also going to go through what to do with that CAD data once you've imported it into SolidWorks. We're going to discuss a little bit of a workflow, as well as if we effectively want to abandon that workflow and just start working with the models directly and making minor but also major tweaks. And lastly, we'll have a little bit of a live demonstration to just talk about everything that we'll be touching lightly. So the first thing that seems relevant to present here would be understanding the types of CAD data. Now, I've collected this list from some SolidWorks users as well, and it's set in order of preference over on the left-hand column. So you've got Parasolid as being the most preferred method for importing SolidWorks models. You've got step file being the next, and as we go down the list, IGES being the least preferred of the generic file formats. Again, this is generic, not software specific. And that bold statement at the very bottom, just why IGES is the least preferred. It was last updated in 1996. So there has not really been any update to the translation method for that extension for now over 20 years. Not to say that it's a bad option, it's just you have to recognize the limit that may be introduced as a result. Then over here on the right-hand side, we've got some native CAD files that SolidWorks can pick up and read with relative ease. They're never perfect, but we're going to talk through the process in a little bit here as to how we can make them better. Now, some limitations. There's nothing that I want to cover here specifically. I did want to provide this information so that you could come back through and possibly take a look at this as it relates to a specific software you may own in the company or another piece of software that vendors are sending you files from. This sort of lets you know what the best case scenario is that you're going to get from those other CAD softwares. So for instance, looking at Creo at the top, it imports and exports parts and assemblies relatively well into SolidWorks, as well as imports body data, feature data, and mate data. But things like materials and your datums may go by the wayside. Now, the best type of export if you are working in one of these file types. So this is relevant if you are looking at things from the perspective of requesting files from the vendor. Here's another breakdown of file types that you can ask vendors who are using, for instance, CATIA. You're going to want a step file from them first and foremost. IGES, if that's all they can provide. And if you effectively don't need to alter the model anyway, an HCG or a CGR, which are effectively just 3D image files, will allow you to just look at what's going on in the model there. So again, another good page for reference and for review, but no action items that we're going to cover heavily right now. Now, import options. If you've ever run into this scenario, you've probably been scratching your head pretty heavily. What's the right option? Answer in short is there's not one option that fits every scenario. If you go through the import options and you toggle every setting that's available, you're looking at roughly 1,500 combinations for the different types of import settings that you could tweak and select, etc. So in scenarios like this, the best import option, in truth, it sounds very tongue-in-cheek, is to just use the information you have. What we mean by that is, if you know it to be a specific file extension, like a step file or an IGES, choose that profile at the bottom. If you know that you were having an issue the first time attempting to import it, where faces were not coming through the way you wanted it to, or it wasn't forming a solid, you're going to want to look for options that would help promote that the next time you try to bring it through. But it really is, it's a scenario of you're using the best information you have and trying to make minor tweaks to it over multiple attempts of importing it in. Now, 3D Interconnect. This starts to answer the question of, do I even need to edit this CAD data? What 3D Interconnect is it's a link between the CAD data, it creates a link between the CAD data as it exists and how it's imported and viewed and translated into SolidWorks. What that means loosely is, if you were to have 3D Interconnect toggled on and you bring in a CATIA file or a solid edge file, you can choose to bring it into the assembly, and effectively all it's doing at that point is referencing the original CATIA file or solid edge file, the original format of the file that exists on your desktop. And all it's doing is acting as a 3D placeholder for this reference point. If at any point you receive a new file that needs to replace the old one, or there's an update, all you would have to do is replace the files. If the naming convention is the same, SolidWorks will always look for references that way. So saving over top of the old file in its location with the same naming convention is going to prompt SolidWorks to update the information, and it'll translate through the model, and you'll have an updated model at that point. To toggle this option on, it's in System Options, Import, General, and then there's a checkbox for Enable 3D Interconnect. It is on by default, and I'll show you what it kind of looks like during our demonstration here in just a moment. So 3D Interconnect is very helpful approaching things from a perspective of, I may need this model in my assembly or recognized in the assembly or on a bill of material, but I don't need to edit it beyond that. So 3D Interconnect is a great way of just saying, we're going to sidestep all those import issues or options, and we're just going to bring it straight into the software so we can utilize it as we only need to. Now we're going to start talking about the options for opening the file. So now we've imported into the software. It may be a little bit ugly. Now we need to figure out what to do with some of this ugly geometry. So first option here is import diagnostics. Now I'm going to describe the next three things and then kind of talk about this workflow that is generated from the three of them. So the first thing you're going to look to do, if you know that there are faces missing, features not quite acting the way as you'd expect them to, if features did come in at all, first step here is import diagnostics. What it does is it identifies problem areas in the model. It's very general. It looks at the model in a very general term. And once it finds an issue, whether it be gaps or unknitted vertices, it's going to attempt to repair those problems automatically. And it's working to ensure that the imported solids are valid, so that they effectively are solids. Once we've run import diagnostics, the next thing would be check entities. This again is just another geometry check. It's a secondary step to the import diagnostics. They do a similar function, but it's a good habit to get in because there are more options in check entity that you could have SolidWorks investigate for you, and will save you a ton of headaches down the road by just running this intermittently in these steps of this process. Once you've run this check entity, if there is an issue, it will show you those issues in the list of results below and give you some more detailed information as to what's going on and how that might be resolved. Last part of this here is the feature recognition. So if you've gotten through the first 2 steps well, you've healed all the faces you could, you've checked the entity and everything seems to be holding up correctly, the last would be feature recognition. What feature recognition does is it attempts to automatically create SolidWorks feature from the imported CAD data. There are 2 major sort of functions that you can perform through this. There's an automatic and an interactive feature selection. What that means is automatic is you just set SolidWorks loose on the model, and it's going to try to look at holes, edges, radiuses, and try to assign a feature to them. Whereas interactive is you would go feature by feature and try to build your tree 1 feature at a time. Neither one works perfectly every single time, and sometimes the right answer is a combination of the 2. Beyond that, there are also feature types for standard features inside of SolidWorks, like your boss extrudes, cut extrudes, etc. And there's also profile for sheet metal components, so you can ask it effectively to just run the feature recognition and potentially give you a nice, perfect flat pattern at the end. And the last bit of it that seems, I think a useful feature is when you're running FeatureWorks, compared to the first 2 diagnostics that we were running, check entity and import diagnostics, this will create a new model for you. It'll open up a new window and try to run feature recognition on this new model, so you're not risking corrupting or obscuring something in your original import. Now, here's the workflow we just loosely talked about, but we're going to talk about in some specific. Did something go wrong? Was the import diagnostic, it didn't quite go as you expected? Did something go awry in the feature recognition? That's fine. Just stop at whatever point. You can revert back to the original import and just run through the checks again. You can even keep it as is and just run through the checks as they are right now, but go through the process again of check your import diagnostic, check entities, or check the model to be good geometry, try to run the feature recognition 1 more time, and if you had selected some options the first time through, try a slightly different selection, or try everything rather than just looking for specific features. And we'll walk through that here in just a moment. The last bit that we're going to discuss and I'm going to demonstrate here is direct editing. Direct editing is useful for, you've got your file imported, you've checked the entities, you've run import diagnostics. We have not run feature recognition because we've hit a scenario where we recognize that this looks fine. All I need is a few more holes, or I need to change the diameter of this 1 hole, or this radius is too big. That's not how we would develop it internally, so I need to make the radius of something smaller. Direct editing is going to afford you to edit your model pretty powerfully, but also in a very simplistic method. So we're going to look at that as well in our demonstration. So let's take a break from PowerPoint. Let's stop talking about it and let's get into some action here. So let's open up our SolidWorks here. I've prepared for us a little demonstration. I created a test file here in SolidWorks and I've saved the test file out as a step file. It's no longer sort of associated with SolidWorks. It's not going to have its traditional feature tree that we're used to having. So this is going to work well for our test here. So I'm going to just go ahead and take this step file, and we could go through the file and open method. We could go through the options for importing at this point, but I'm going to just show you what it would look like from a very brass tacks user perspective. So we're going to just drag and drop the file in there. We're going to take the import settings as they are. I know that I could get better functionality out of them, but I'm going to pull it in as is. I've also done some testing on this, and I know that the geometry is such that it's not going to fight us too hard. So as soon as I bring it into here, it's asking us to run import diagnostics on this part. That's great. If you don't want to see that message pop up every time you have a non-native SolidWorks part, you can check that box and answer the question there. I'm just going to exit out of it for right now. So here we have our step file. It's been imported into Solidworks. There's nothing about this that suggests, intelligence as far as what I can roll back, what I might be able to edit. And the first approach we're going to take with this is I want to make sure that it's correct before I start attempting any editing. And I'm going to try to run feature recognition on this. Emphasis on try. So here we go. As you can see over here, we've got we can see in our tree right now, there's a body for this. So SolidWorks is already suggesting that there's a healthy, at least solid body here. It's not split into surfaces or faces. And down here, we've got what looks like a part icon and this green arrow pointing out. What that symbol means is 3D Interconnect is currently active. And this is the symbol to notify that Interconnect is currently working. So what it's doing is it is looking back toward this step file, and it's making all of its references from the step file as it exists right now. If I were to save a change over top of it, we would see our model dynamically update because it's holding that link. If I want to begin editing, the first thing I need to do is disable that link and effectively break it so that I can start editing it and say, I want to ignore its previous reference. I just want to focus on it as is and start making edits to it. So I'm creating a new file from it effectively. So in order to do that, I'm going to right click on here. I'm going to dissolve this feature. When I ask it to do that, it's again bringing up this warning message, letting me know that I'm about to break the link to the original CAD data. Yes, I'm okay with that. And once I do it, we can see that it now is just viewed as an imported solid. There's no other information, but I've severed the link between this CAD file and the step file that previously existed. So now I'm going to go through our process that I've outlined. I'm going to right click on it and I'm going to run import diagnostics on the geometry as it exists. So I'll click on that. It runs it in the background quickly, and if it had found anything that it needed to heal, fix, etc., we would see faulty faces or gaps show up in the boxes over here on our left-hand side. And all we'd have to do at that point is attempt to heal them or heal them in a more specific profile. Right now, it looks like just running the import diagnostics has not found anything, which is great. I'm not going to stop there. I'm going to go a step further. I'm going to come up here to our features tab, or excuse me, in my evaluate tab. I'm going to check the geometry. I want to make sure that this is sound. So I'm going to have it check pretty much everything that I can. I want it stringent, solid, and surface check as well. I want to make sure there's no gaps, holes, or anything. Run the check, and good. No invalid edges or faces found. I'll even ask it to look for short edges. It's found a couple of short edges. Those aren't anything to really call big concern to me at the moment. I think we can work through them, but it's good to know that I have them there. So we've run the check entities. Nothing is invalid. I have short edges. We'll work with that. So I've run my 2 checks. Now it's time for me to attempt my feature recognition. So I'm going to come down into feature works after I've right-clicked it on that imported body, and I'm going to ask it to do feature or recognize features. Now here's my feature works panel over here with all of my options. I got there's 2 modes, the automatic or the interactive, where in interactive, we would basically just be going through feature by feature, clicking on faces, trying to get it right to recognize. We're going to take a stab at automatic. This is a sheet metal component here, as you can see. So I want it to treat it as such, and I want this to generate a flat pattern from me if it can. So there are a series of options in which we can have the software look for as far as what features it needs to recognize. I don't imagine that there are any ribs in this. I don't imagine there's any hems in this. None that I can see. Edge flange, sketch bend, base flange. I don't think there's going to be any revolves. We can keep these things checked off just to try to shorten the amount of calculation. We can also just keep everything checked on and make an attempt at it one way or the other. I'm going to turn some of these off just to try it through this first time, and we'll see what happens from there. So again, I'll ribs, I'll leave holes. I don't think there's any revolves. And we'll leave everything else checked for the time being. It's asking for a fixed face, so I'm going to select the bottom as that fixed face. And I'm going to hit the check mark here. Now this will take a few minutes as it runs through the calculation, tries to figure out how to build this. And as you'll watch it sort of go through, it's going to effectively look at the model at its selected face, and it's going to slowly try to build it up and out from there. So we're seeing it load. It's making an attempt at solving this. And let's see what we've got here. All right, we've got possibly some interesting things going on here. Certainly more features than I may have considered creating for myself. But let's see what the flat pattern looks like. Let's see how it translated. Click on flatten. Flat pattern looks sensible to me. And if I'm importing this model in for the first time and this was my end goal, I've now reached it in a matter of minutes without having to recreate the model, go through anything hyper complex. If this were to fail and not create a flat pattern that I was ideally after, that's okay. Because as I had mentioned, when I highlight down here, our original part is still here. You know, we still have the ability to go back through and try to recreate some of the feature recognition from this model that we've already confirmed that the import diagnostics and the check entities came through, suggesting that it's a healthy, ready to go imported CAD data. But from here, I now have a fully realized feature tree. The feature tree, again, might not be created in a method that makes the most sense. Feature recognition is not always looking for the fastest path or the most efficient means to reach a solution. It's, you know, every cut is going to effectively be recognized as a separate one inside the model. So if it feels like there's a little extra in here, the reason is because there is. Case in point, you can see that this cut extrude right here is just recognizing one feature. That easily could have been done to, you know, recognize this cut down here, even those at the bottom of it, depending on when they were created. So not hyper efficient, but you really can't argue against the speed of it. And now it's a sheet metal component. I can continue adding edge flanges onto this. I can continue editing it the way I'd expect to in SolidWorks. It's ready to go at this point. Now let's look at our previous imported model. And we've gone through feature recognition and we see the power that can deliver for us. Let's assume that I only need to make minor edits to this as it is, or even beyond that. Let's assume that feature recognition just failed us. It's a complex procedure to run, and the results are not going to be perfect every single time. So let's say one of those two scenarios occur, but I still need to manipulate some of the data here. We can do that through direct editing. So direct editing is just another tab that you can add to your workspace up here at the top. You'll find it here underneath your tabs. Direct editing has only a handful of options, but I think you'll come to understand how powerful each one of them are. So with direct editing, again, all I have is an imported solid here. Verified that the geometry is good, and that's it. No, nothing else has been done to this. Let's say, for instance, that this sheet metal component is exactly as I need, but these edges are considerably too sharp. There's no way we can produce this and have this exist in its environment. We need to soften those. In import diagnostics, or in direct editing, we can add chamfers and fillets on the edges if we so choose. You have basically all the same options that you had previously from fillet creations. Hit the check mark there. I didn't have preview toggled on, but we expect to see our edges filleted now, so we can go around and soften edges. As I mentioned, we can also create chamfers on top of any of our edges or corners or etc. So we have that functionality to just loosely edit things inside of our model here. Beyond that, we have the ability to pattern things. So if this hole is a feature that I need to add more of, for instance, let's choose the direction of our pattern. Let's add a spacing instance of 1/2 inch. Sure, we need 5 of them. The mounting requirement for this has grown tremendously. And rather than looking for features or faces, we're going to just choose only faces down here. I'm going to choose the 2 arcs of that hole. I'm going to hit OK. And there we go. We just patterned basically a featureless feature here inside of Solidworks. So we're making these little edits without really needing to get in and see a feature tree. The upside is we have a feature history for what we're doing so far. So we're able to go through and make edits to that as well. Now I'll show you a couple of other sort of power moves basically that really make direct editing a very useful tool in my opinion. Let's say for instance that this sheet metal component that came through is not the right thickness. I'll click on an edge here and measure, showing down here that it's 0.60, so that's too light of a wall. We need something that's a little heavier gauge, and we need that corrected effectively. So let's go ahead and play with that. What we can do here is we can just basically extrude the faces. We can offset the faces a little bit and move them to give us an increased thickness. So let's come here. The first thing I'm going to do is I have to eliminate a couple of radiuses. And to do that, I'm going to delete this face. So I'm going to use the delete and patch function right here. I'm going to click on this radius over here, that one underneath there, hit the check mark, and what you just saw happen is it automatically deleted the face out of there. It used the surrounding geometry to patch it and make something that made sense for the constraints that existed. So we just patched that face. I now have a nice flat. I could go through and do that. We'll do it over here on this other radius as well, because 2 examples always beat 1. And I've got my corners nice and squared out, at least in these 2 arenas. Now I'm going to ask it to move this face. I just needed to translate it, which is a physical move. This is the face I'll focus on first. The direction in the line is fine. I'm going to give it a movement direction, so I'll just click on this upper edge. And you can see a preview is already showing. What's the distance? Do I want it 0.1 off of what it was previously? No, I need it to be something specific. So I'm going to say 1/8 of an inch is what I needed to move. I'll subtract the known thickness of the component as it is right now. That's the distance I want to move it. Hit the check mark, and we can see that I've now made this portion of it thicker. Now, all I'd have to do at this point is repeat the process that we just exercised, where I am moving this face down here, removing any of these fillets, and we're effectively going to complete this by having all the faces translated to something slightly thicker. Now beyond that, let's say for instance, and to get it back to where it was previously, we've already verified that fillets work. So just pick the appropriate radius for your fillet. And you can, again, simulate this as a sheet metal component. Let's say, for instance, that your business is an injection molding business. This tray came in from a vendor that only does sheet metal, and you want to convert this into something that's basically more rigid. We can do that as well. I'm going to use the delete face option once again and run through this a little bit more quickly. I'm going to delete those faces there. I'm going to run another delete face on this selection here, and what I'm going to do with this is instead of delete and patch, I'm going to ask it to delete and fill. Now what that did is it got rid of that center section where the radius used to be, and it's cleaned up that edge a little bit more for me. I've already got this edge flattened out. This will work even if I don't flatten that out at the bottom. But let's keep moving some faces here. So I'm gonna translate. I'm gonna choose this edge to translate, and I'm going to give it a selection up to this surface. We can see a preview of what's about to happen here. I'll hit OK. I've now got one flat surface here, so I'm going to move this as well. Again, I want to move it up to a surface. I'll select here. We can see a bit of a preview of what's about to happen, and we can see that I've now fused that corner. So with direct editing, I'm taking something that was sheet metal and converting it back into basically standard methods of modeling with your extrudes, cuts, and etc. You know, we're exiting a arena of sheet metal modeling that doesn't require it. A couple of things that are worth here would be move phase command because it doesn't just translate, also use it to change diameters of holes if need be. We've got options inside of here for moving faces like rotate and offset. Let's do the offset right now and look at this hole over here. I'll select this and you can see that it's providing us a 0.55 offset. I'll just give it 1/8 of an inch. If we flip the direction, I can change the sizing of this. Let's make it a little bit bigger, for instance. And we can see I've just opened up our little cutaway to something that falls more in line with what we're after. Moreover, this cutaway that we have over here is no longer required. Let's just get rid of it. Again, let's do a delete and patch for this one. Hit select, and we've gotten rid of that. So I hope you can see that direct editing sometimes is enough to sort of get the geometry where it needs to go. In the scenario of a sheet metal component, it may make sense to get feature recognition working so you can work with it in a sheet metal capacity. If it's not, and it's just general modeling techniques, this can more or less cover all of those. So that's my time. That's my presentation on direct editing. I hope you guys, or not direct editing specifically, but dealing with SolidWorks files that are non-native, I hope you guys picked up a few things. And if anyone has any questions, love to hear them in the chat. There's a section in the questions where you can reach out and ask me anything there. Yes, for anyone to view and observe if something was missed there, but all these techniques are worthwhile techniques. There's obviously more that can be uncovered as we're dealing with bringing non-native files into SolidWorks, but I'm hoping that this will validate the idea that really two things. One, if you have a model that is not non-SolidWorks related, there's no need to start that file over from scratch. There's something that SolidWorks can do inside of it that can help translate that data into useful information to you. And the other one is basically be curious, try some new things. If at any point you get stuck, that's why we're here. So please reach out to support, ask any of your colleagues, but SolidWorks has a bevy of tools to solve a myriad of problems. So if at any point you guys need further assistance, never hesitate to reach out and ask questions. Thank you guys so much for your time today. It's been a lot of fun sharing this information with you. And as always, I hope everyone has a great day, stay safe, and we look forward to connecting with you in any way that we can. Thanks so much. Have a great day.